Welcome to my talk. We're going to discuss my field notes on hunting authentication and authorization bugs that originate specifically from user registration stuff. So think web applications, mobile applications, or any network service which allows new users to register, mostly via web-based HTTP APIs, but these concepts are more or less applicable to pretty much any network service. So security engineers, bug hunters, developers will definitely appreciate some of these techniques, and they're probably even familiar with some of these. So let's begin by a little bit of my background. I'm a senior red teamer at Microsoft, fairly active in bug bounties, responsible disclosures. Research interests are usually AppSec, IoT, in Azure, as well as network security. I'm not so senior blue teamer at home because you have a toddler and an infant who are always trying to defeat all your restrictions you put on them, right? So they are the real-world threat actors. All right, so this is going to be our agenda. These are all from first-hand red teaming experience. All of them are fixed, but there'll be no naming and shaming because NDAs and stuff. But these are alive in pretty much, no matter how secure the service is, definitely try. So a little bit of why, because as you all know, authentication is the weakest point in any system. Right, so if you attack that, the whole system falls apart. You don't even need to, escalate your privileges in there. So once you are inside, get a high privilege within the application, you don't need domain admin or stuff like that, right? And these things usually lead to account takeovers. Probably just take over the account of the most privileged account within that system, right? Could be administrator or someone else. These techniques are manual, more or less, which means there is very less noise and there will be virtually no detection because the defenders don't actually know what they're looking for, right? Because everything on the back end is looking as if it's coming from a legitimate user themselves, right? And then we'll also discuss pre-registration account takeover, which is basically if an account does not exist in the system, but we can still control it until the real user arrives. It's still exciting, although not super exciting, but it is. So a little bit of how authentication currently works. All of you must have played this password game, right? About password complexities. What it usually leads to is things on the right, like extremely weak passwords. So someone thought about it, and then they said, OK, nobody's going to use a password manager on their phone. Forget about even on desktop. And because now everything is now an app, even apps which don't pretty much do anything, but they're still given as app. So the solution was one-time password. Your phone number is a proxy to your password, right? So what can go wrong here? Because so OTP originally in crypto sense, like crypto as in cryptography, not crypto mining, was one-time pad. It was basically a string of highly random characters, which was only supposed to be used once and never again. The problem was that it was impractical to securely share this string in advance, right? That's the whole thing of symmetric key encryption, which is key management. So if you guys cannot actually securely share the key, if there's a way to share securely the key, then there's a way to securely share the data themselves. You don't even need encryption, right? So that was the origin, one-time pad. Now, of course, you guys know OTP is one-time password, which has a similar origin. So let's look at the case studies. So this was a chat application, which is just a phone number. Think of it as it uses an email to sign up. The phone number is verified, but there was no verification of email. So you sign up, you say, OK, I am Joe Biden at whitehouse.gov. But you use your phone number. So your phone number, you will be sent an OTP to your number and then you register. So what can go wrong over here, right? So the easy stuff is obviously you take over any unregistered email, because if certain user doesn't exist on that platform, and there's no verification of email, and by verification I mean like if once you type in your email, you should get an OTP to your email too, so that you assert that you own that email too, and not just the phone number. So you get into that. So obviously this leads to user repudiation. This is how the post request looks like. As you can see, the registration request looks like you can pass in any email. The platform device ID doesn't matter. It's like just random stuff. So now I own Joe Biden at whitehouse.gov, right? So this is a response. It's like 201 created. So certain things of interest. You see, you get passed a user identifier back. You get the email, which obviously you passed, and then you get like a long P, which is more or less like a pin you get back. So I don't know what to do with it, so I'm just going to keep it in my back pocket for now. And let's level up. Now, once you have registered, I've started enumerating all the HTTP APIs, like how the application themselves functions, right? And then I found an endpoint which would return the authentication token, like of the logged in user themselves, which is not exactly a big deal, because every application has, sometimes some kind of API where it just returns your own token, which is fine, right? But in this case, when I chain these two vulnerabilities, you can kind of maintain a persistent access. So we're going to see how. Remember the long pin which we get there? Once I was able to, and then there was this registration endpoint which was still active even after the user was already registered within it. So you see that user ID and you see that long pin. As you can see, I can get an access token back, which is for the same user, right? So far, that's good. But then what happens, right? Somebody tells the victim account, like, okay, you have an account, you should own your own account, right? Because someone else already has taken over. So what is going to be the next step? So as a victim, obviously you will try to do a forgot password or something like that, right? Because you know your email has been taken over, but your phone number is still verified, right? So you just hit a forgot password with your own phone number, and you can try to get access to that email. So let's say the legitimate user does that, but even after that, remember that token leakage? I have it, that's a static token, so I still own that account, and they won't know about it at all, because now I'm just going to hit all the APIs using that token, and then I'm still getting access. So in this exploit, I'm just basically changing the phone number again, using that authentication token, which I got before. And then, as you can see, I have changed that, and I still own that account, even though that user has verified their phone number and stuff like that. So we are kind of attacking the human angle as well here, right? Because now this is a chat application. What are you going to trust more, like, right? So in this example, like, for example, what do you guys trust more, like a fully qualified domain name or an IP address, right? Obviously, the FQDN, right? You guys trust the legal name or the passport number? Because nobody is actually, knows the passport number of other person, right? Or even a crypto wallet address. That's the whole thing about wallet addresses, right? Because those are very difficult to remember, right? Email address or a phone number. So obviously an email address, right? I could change the phone number and own that account, but you're going to search the user by the emails, and you're going to trust that more, right? So pretty much you get that. So I reported that there was a positive ending to this. They were like, the registration endpoint should not even be active post-registration, and obviously, no API should return sensitive information, let alone the authentication token. So the lesson here is like, pre-registration ATO, nobody's gonna, even bother with it. But then when you chain all these vulnerabilities, you get like a really high impact vulnerabilities. For example, in this case, it was the lack of email verification, the return of sensitive information, even post-authentication, and even just for your own account. You can see there's nothing no big deal in that. But then registration endpoint, is still active post-registration, you just chain all these three, and then you get like a high-impact account takeover for pretty much any user within that system. So I would encourage everyone to, just not leave such low severity vulnerabilities on the table. Always find something more, and you can get that. All right, moving on. So number 2. So this is about single sign-on, where you don't actually attack single sign-on, but find ways to move around it, more or less. So let's do like a 2-minute crash course on single sign-on. So in a single sign-on structure, there's usually an identity provider, which is like Google, Facebook, Microsoft, LinkedIn. And then the client is obviously your web browser, your mobile browser, or any kind of a service which originates from the client. And then there's a service provider where you're actually trying to access some service. So for example, let's say this chat application, which redirects you to the SSO provider, and then you enter the username and password there, and then it redirects you to the client, which gives you a token, and then the token is sent back to the service provider. So the way trust is shared between these is like this. Like between the IDP and the service provider, there's a client ID, client secret, which is done during the setup stage. And then this is how this flow is, which I basically explained, that the client initiates the flow. The service provider redirects to IDP, where they enter the username and password, and then you send the signed token back to service provider to get access to whatever they were trying to access. So as you can see, this is crossing multiple trust boundaries, and I'm not even going to discuss like OAuth-based or SAML-based attacks, which are very well alive, but we'll just focus on the application layer. So in this scenario, they were doing SSO very rightly. They were using Azure, which is Entra now, Entra SSO. But however, they added like an extra step to the authentication process. And this is what it looked like, the post request. So this was like a multi-tenant application which was doing authentication, and it was hosting a bunch of corporate data. And this was initiated from the Android. So the only secret, so after authentication, you get back a token from Entra ID. However, they were exchanging that to get another application-specific token. And this is what the request looked like. So the only things which we need to know is the merchant ID, because as I said, this was a multi-tenant application, so every merchant had a GUID, which was unpredictable, but you can kind of leak it. It's kind of public. So at the very least, you have access to all the accounts within that particular domain, so your company in this case. And then if you can find ways to get leak another GUID, you have access to those as well. And then there's a tenant name. It doesn't matter. It's like it could be any company name. And then the user ID was the AAD object ID, which is, so when you enumerate Active Directory, every user principal name is identified by a GUID, which is also known as the Azure object ID. Those are different. On-prem, those are different. On cloud, it's different. But it doesn't matter, because anyone with directory read access, which by default you already have, any user within your company can enumerate those. As everyone with Active Directory experience might know, you can pretty much enumerate all Active Directory objects, at least the read access. And if you have write, that's like a totally different issue. And then there was this email address, which was like just user@domainname.com. So that got me thinking, like, okay, so there's technically no secret except the email address, which is like weird, right? So it more or less boils down to knowing just the tenant ID and the user's email address. And this is how the response looked like to the previous request. It gives you a token, which was specific to that application only. And then the merchant ID was like basically a return of whatever we sent in, right? And this token provides full access to any user's account. Now, this is like an example of full account takeover without even touching any of the user, right? This is not going to be detected. But yeah, this was like a jackpot for me. Like, And I could do it for multiple tenants as well, because I found another vulnerability where you could do it. So in this case, like even though just using single sign-on doesn't prevent you from shooting yourself in the foot, if you don't do it correctly, there are like pitfalls like this. AAD object IDs are not secret. Use a real secret. Like just use the JOT token, verify it, validate it before accessing any of the APIs in the next step, right? All right, so another SSO case study where they are just blindly trusting the SSO provider. So remember the diagram where there's the SSO trust boundaries, right? So there's a trust boundary between identity provider and service provider, which basically is based on client ID and client secret. The thing is, like, the service provider is trusting pretty much everything the SSO provides back. So like a name, email, phone number, whatever it is. Now the thing is, like, you are trusting the single sign-on provider to do all the verification validation for you. So think about pretty much everything, like full name, email address. You trust that they have validated it. Phone number, you trust they are validating it. Because now you're using that values which are coming from the identity provider, right? So in this case, one of the SSO providers was allowing registration via phone number, but they did not actually validate the email address, which is fine. It's not, again, not big of a deal, right? However, once that request has come in to our application, it becomes difficult to validate, like, which is true, which is not, right? So at the very least, this can cause denial of service, because you can just tamper with any of the email addresses which is coming from the IDP, and then it would lead to like pre-registration account takeover or something like that. However, in this case, because you're using SSO, by design there's no password reset, right? Because the whole point of using an SSO is you guys don't do management of passwords, right? You just outsource it to the SSO, make sure, like, okay, they'll handle everything, password storage, password management, stuff like that, right? Which is good, right? But now in this case, it becomes a problem, because a legitimate user cannot actually reset their password without opening support calls and stuff like that. So this is what the request looked like. So after this is when the user is actually being registered. So if I have to pass in the email address where I hijack this account or something like that, and then the authentication provider ID was pretty much like, it could be some unique identifier, and then the identity provider was like, Facebook, LinkedIn, or whatever that was. And the application blindly trusted all of these values. So your name, email, phone number, whatever that was, thinking that those were already verified at the identity provider, but this is all like basically tampered by the end user. And this totally works. So lessons, obviously trust but verify, And if the identity provider is not doing the verification, this is going to lead to account takeovers. For example, if this account already existed on your application, this might lead to full account takeover. In this case, it did not, but it could. All right, moving on to case study number 4. We're going to deep dive into any RFC, in this case, the email RFC, which is 5322. So we're going to play a game. So everyone is going to answer yes or no. So I have a bunch of email addresses, and you're going to say if it's valid or not. All right, so number 1, space between quotes. What do you guys think? Is this? No? Yes? All right, it's a valid email address, as per the RFC. Let's move on. Quoted double dots. Yes? All right, it is valid. Non-letter characters and multiple @ sign. The first one is a double-quoted one. See, there's one drunk guy who's like, yes, of course. Yes, it's valid as per the RFC. IP addresses instead of domain name. It is valid. You guys know it now. Slashes within the username. Yep. Yes. Local domain name with no top-level domain. Yes, that's a valid one. So as you guys see, there are like so weird email addresses which are valid as per the RFC. So when you are registering your email onto any application, the application has to do not just the verification, but also the validation of all these weird things which are happening. So in one of the cases, the application which I was assessing was like a Java application, and it was being run via the standard Java validator, this particular class, which is like internet address.validate. And now, obviously, it has to adhere to the RFC, right? Otherwise, what is the point, right? So as penetration testers, security engineers, the first thing you will be like, oh, if angle brackets are allowed, or if quoted signs are allowed, what are you going to try, right? Obviously, you're going to try to do something like XSS or stuff like that. But what are the targets here? Like if you are still able to get that email address registered within the application, you will get like an email like saying that, oh, you were successfully registered or stuff like that, right? So the target is mostly mail clients. It could be a web-based client, it could be a thick client, it could be a mobile client, and I don't know, people access their email even on terminals, right? So it could be that. Whatever would execute JavaScript or stuff like that, right? And the client doesn't matter. It could be Outlook, it could be Gmail, it could be Apple's inbuilt, mail client. So, however, they are very, very strict about executing script. So we did some research. We're like, okay, we can't do script, and even after doing script, we probably don't have much to gain here. So, however, modern mail readers have significant CSS capabilities. So, which means you could embed style tags within the email addresses, and both of these are like perfectly valid email address as per the RFC. So, and then there were like some character limitations, but it doesn't matter for our purposes because you could just run it through a URL shortener and get it there. So in this case, what I did was like basically hit an import statement on CSS, which would load external content, and the mail reader would try to render it. So this is what the CSS looked like after developing the exploit. We just did a body where in the beginning it's hidden, and after the body is loaded, which means when the user opens up the email, you could just replace the content. So in this case, it was like just enticing a user to click somewhere else, right? So this is like some account reset page or some phone number which we control, and then what are the chances that the user will not do that, right? Because now this is coming from a legitimate service. It's not even a phishing email or something, right? It's coming from whatever, no reply at application.com, right? However, some clients will still warn about loading external content in the sense that because now I have embedded like an HTTP link, so they'll be like, oh, do you want to, like, for example, Thunderbird did warn us, but what are the chances people are going to say yes, right? Because think about it, it's coming from a legitimate email, it's coming from, you expected that because you registered that, and then, people will actually do that. So you're attacking the mail client, right? Which is like super cool. All right, last one. We're just going to hit double dipping. This is like a really textbook example of account takeover, but I just wanted to show it because like things like this exist. They are like very alive. And this is like so dumb I can't even talk. But this is like $1 billion home improvement retailer in the US. So this is what the HTTP request looks like when I try to register a new user. It's just an API endpoint to the profile. You say the user you want, username you want, the password you want, and the user ID you want. Like it could be random, right? And then two cases, right? If the user does not exist, this is what the response looks like. I get a user identifier, I get the user ID, which could be random, and then I get an API authentication token for my user, right? Which is good, right? However, if the user already existed, I would get an ID, a user ID, and an authentication token. I was like, this is I don't know. What's wrong, right? So I started testing. And then, like, whether this authentication token is actually useless, might be dummy, who knows, right? Because services do a lot of stuff for default user accounts. And actually, it turns out, so when I just did like a test on, getting profile details for my user using the authentication token I already obtained for another user, and it looks like it totally works for that user, which is like, it's like a textbook level account takeover, but such things exist, so do not give up. All right. All right, so yeah, we are almost near the end. So this is like a cheat sheet I developed where, if you come across for any application doing user registration, self-registration on their own, definitely check for, for example, they're doing out-of-band authentication channels, right? The first thing is, are they verified or not? And denial of service is the least you are going to get, right? So, and there's a difference. And then check if there are like extra steps. Like it has to be like clean as a slate, right? Because even if you're using single sign-on or any kind of service where you outsource the authentication, there are opportunities in tampering. There are like a lot of them. So basically, anytime a data crosses trust boundaries, there are opportunities, and people will exploit it. Self-user registration, obviously, like a bunch of AppSec things like sanitation, error message disclosure, or bypass any checks for API access. For SSO, all attacks are definitely valid, like signature wrapping attacks for SAML, XXC for OAuth, and OAuth's two specific attacks where you tamper with redirect URLs. You can do a lot of stuff there, but those are like, very specific to technologies, but definitely look after them. If email address is accepted, obviously it has to, right? So you need to remember that email address validation is not the same as email address sanitization. So as we see, like looking at the RFC, there are a lot of crazy things can happen. The onus is on the application developers to make sure that none of the unintended consequences arise due to that. With that, questions time, feedback time. Thank you so much for being an awesome audience.